Hi guys, I'm going to review the acid nomenclature notes from earlier today. So a few notes on polyatomic anions. I went over this in a previous video, but I want you to remember that the per 8 ions have a very high number of oxygens. The 8 have just a high number. Ite has a low number of oxygens, and hypoite has a very low number of oxygens. And then lastly, anything that ends with ide typically has no oxygen, with a few exceptions. Okay, so let's use chlorate for our example. Chlorate is ClO3 minus. So perchlorate is even one more than that, meaning one more oxygen, ClO4 minus. And chlorite, that ite ending means it has one less oxygen than chlorate. And hypochlorite has the fewest oxygens with just one. And then lastly, if I had chloride, that ide ending means no oxygen, so that's going to be just Cl minus. Okay, hexafluorosilicate and thiocyanate are the only 8 ions that have no oxygens. This was meant to be over here. They have no oxygen atoms around them. Thio means sulfur and cyanate is like cyanide. So that is the formula for thiocyanate. Hexafluorosilicate. Hexafluoro means I have 6 fluorines, and silicon is with it, and it has a 2 minus charge. Okay, hexafluorosilicate. All right, moving on. In order to name acids, we have to know how to use these polyatomic ions to name some ionic things. Because an acid is like an ionic compound where we have ions combining, but instead of a metal bonding to the nonmetals, it's going to be hydrogen, the hydrogen ion bonding with those nonmetals. So for calcium, CaCO3, that is calcium carbonate, because I recognize that the CO3 with my metal, so metal plus nonmetal makes ionic. Remember, that's really important. Metals plus nonmetals equal ionic. Okay, down here for acids, we're going to see H plus and nonmetals make an acid, make acids. Okay, so the H plus is the special ingredient that makes it an acid. Up here we have metals with nonmetals, so that is calcium carbonate. You might be recognizing the NO3, hopefully you are. Mg is magnesium, and NO3 minus is nitrate. That's part of my T group. K is potassium for the next ionic compound, potassium, and SO4 2 minus, because if I uncross that charge that went down to the potassium, it came from the sulfate. SO4 2 minus is sulfate. NaHCO3. Na is sodium. And you guys might recognize the CO3 from up here. That was carbonate. But it has a hydrogen stuck to it. So there's 2 ways I can name it. I can call it sodium hydrogen carbonate, or the way that we usually call this one, sodium bicarbonate, should sound familiar because that is baking soda. Okay, and last but not least, NH4 is kind of a tricky one. NH4 is called ammonium. Okay, and it's actually NH4 plus, and that's being combined with NO2 minus, and when these two come together, their charges cancel, and we get ammonium nitrite. So the nitrate was NO3 minus, nitrite is going to be NO2 minus. Okay, so now that we know how to use these to name ionic compounds, let's learn how to name some acids. If you have a per 8 ion, for example, let's use a different one. We used chlorate earlier. Let's use perbromate. Perbromate is BrO4 minus. That is going to change when you make it into an acid by combining it with H+. That's going to change to an per-ic acid. So the 8 ending goes away and we change it to ic. So that would be per bromic acid, and I forgot to add the H here. So that would, instead of BrO4 minus, that would be HBr. Okay, HBrO4. That is per bromic acid. For bromate, is going to be BrO3 because it has one less than per bromate with a -1 charge. And if I add hydrogen to that, I get HBrO3. And that's going to be named, instead of bromate, that's going to be bromic acid. Okay, the ite ions, so bromite is going to be BrO2 minus, and as an acid, that would be HBrO2. HBrO2, the ite ending changes to an OUS, so that would be bromous acid. Okay, and then hypoite, so hypobromite is BrO minus. As an acid, I put an H in front, HBrO, and that would be hypobromous acid. Okay, and then we'll have to get to the ide down below. Okay, so that is the pattern. If it ends with an 8, the polyatomic ion ends with 8, you change it to an ic acid. Okay, you ate something and it was ic. If it ends with ite, then you're going to change it to us, OUS. Okay, so our examples down here, sulfate, SO42 minus. You add 2 hydrogens out in front, and that becomes H2SO4 because we have to balance the charges there. The 2 minus means that I need 2 positives, and that changes from sulfate, the 8 changes to ic, sulfuric acid. Nitrate is NO3 minus, so adding 1 hydrogen to HNO3 changes its name to, instead of nitrate, it's nitric acid. Nitrite, you add 1 hydrogen and change it to HNO2. Its name changes to nitrous acid. ClO minus is hypochlorite. The ite ending is going to be dropped. I add 1 hydrogen and make it HClO, and that is going to be chlorus. Whoops, I didn't leave myself room here. Let's write it down below. That is going to be hypochlorous acid. Right there. Okay, so hypochlorite as an acid changes to hypochlorous acid. Okay, so that is how you name the acids that contain polyatomic ions like SO4, NO3, NO2. Down here, this is a little bit different. Naming binary acids is actually a little bit easier. There are only about 6 binary acids. This is almost all of them that you find on the periodic table. And you are going to add the prefix hydro. Okay, so we put hydro out in front, and then we drop the ide ending and change it to ic, and then add the word acid at the end. So, for example, chloride is just Cl minus. So I have 1 element here, just chloride by itself. If I put that with H plus, I get HCl. This is a binary acid because there are only two elements involved here. And the name of this is going to be hydrochloric acid. Okay, HF. HF is also binary. Those are only two elements. So it's going to have the prefix hydro. And then the root for fluorine, FLUOR, that's hydrofluoric acid. HBr, these are real easy. You can guess what that one is. Did you say hydrobromic acid? You're correct. Okay, and H2S. Notice I have two hydrogens now, but it's still just two elements, hydrogen and sulfur. So this is hydrosulfuric acid. And lastly, hydroiodic acid. Okay, hydroiodic acid. That's it for the binary ones. So those ones are easy peasy. If you guys have any questions about naming acids, make sure you send me an email and we'll set up a time to go over this some more. Have a great day.